Hi there, I'm Andy and I'm the current owner of a 7 1/4 inch gauge HOLMSIDE locomotive designed by Martin Evans. Unfortunately, the locomotive is now in need of a new boiler. As a novice model engineer, I'm going to attempt to build that boiler and then inviting you along with the ride to see how a novice goes on building a boiler in the hope that it might give other people confidence to have a go themselves. It is a 7 1/4 inch gauge locomotive, but the size of the locomotive and its boiler in particular means that the boiler is no larger than perhaps a large 5 inch gauge locomotive. So bearing in mind I am a novice at model engineering, I'd like to invite you along with the journey of me attempting to build this boiler. So let's just have a quick look at the drawings of the boiler that I intend to build. As we can see on this top head here, it's for a HOLMSIDE boiler, and that's at 1.5 inch scale, which will give us a 7 1/4 inch gauge, and it's designed by Martin Evans. If we look down to the right hand side of the drawing down here, we'll see what sheet number of the set of plans that this sheet of paper actually is. So this is sheet 5 of 10 drawings to build this locomotive. For copyright purposes, we can see that I've placed pieces of card over the dimensions of this boiler. As we can see, the general arrangement of the boiler is going to be made from copper material, and all the joints in the boiler will be silver soldered. There are bushes and stays to increase the strength of the boiler. Here's a bush, and here are some other bushes in the front tube plate. The bushes are either made from gunmetal or copper, and the stays, which are further back in the firebox area, are made of mono or gunmetal. We can't use brass anywhere on the boiler itself because the brass would dezincify over time, and our steel would rust. The brass bushes would waste away with the effect of the steam and the water in the boiler, and eventually the boiler would fail. So it's got to be made of copper, mono or gunmetal all the way through. So looking at this drawing, we might think that it's all very complicated and there are several parts to this. This is the side elevation of the boiler. This is the tube, and these are the front plates and the back plates of the firebox. We have an outer firebox which goes from there to there, and an inner firebox which goes from here to here, and over the top of the inner firebox we have a girder stay here, or a crown stay. So we'll have a look at all these components that we need to build this boiler, and we're just going to have a quick look over this drawing to find out what the dimension markings are that you will come across when we're looking at all of this. Let's firstly think about the boiler barrel itself. This is the boiler barrel here. On the HOLMSIDE we have a choice. We can either have the boiler barrel going from here to here initially, or we can have the boiler barrel going from here all the way to the end of the back plate. That's an option for us. If we chose to do that part of it all the way to there, then we would have to make a cut at this position here in the bottom side of the circle, if you like. And when we cut into the bottom side of the circle there, we would have to take the bottom side of the circle and pull it out, lift it up like that, so that it actually forms a plate at the end here over this positions here. From there to there would appear to be a plate at the end of the day with a round barrel protruding from it. The other option is to put the tube plate from here to here joined to the boiler by this ring here. There would be a ring fitted internally of the boiler to join this new flat piece that we've bent into a particular shape to the round boiler barrel. On the home side we have a parallel boiler, but on some locomotives the boiler isn't parallel, it's a tapered boiler, so it would start small at the front and get bigger at the back. With a parallel boiler we have the option of just getting a piece of round tube, the right dimensions, and cutting it to length. That's a more expensive way. Or we could get a piece of flat copper, and as this tin has been rolled round and joined here, we could also do that with this barrel, such that we would just have an open tube, open at this end, open at that end, and we've wrapped it round to form a round barrel, and we've joined it there. There are different methods of joining it. We'll come across those when we talk about building the boiler barrel itself. So let's move on now to looking at this front tube plate here that would be pushed into the boiler. If we look here, this black area, we can see that that resembles silver solder, because this round tube plate here is supposedly a push fit inside the boiler barrel, and the silver solder then holds it in place against the boiler pressure inside the boiler, trying to push that plate out. The boiler barrel, because it's round, it's got its own strength, but the tube plates being flat and a lot of the boiler plates being flat over the firebox end, they need extra strength because the flat plate has no strength against pressure pushing it or bending it. So the plates are drilled and have stays which link the two bits of plate together. If there were two bits of plate like that, the stay would just go through, be soldered onto this piece here, and also be soldered onto that piece there, holding the two together so that they can't splay open like that. Otherwise they would just belly open with the pressure that would be inside the boiler when it's built. So that's what these are. These are stays holding two copper plates together. This here is a girder stay over the top, or a crown stay, to prevent the top of the firebox being pushed down by the pressure that's up here. The steam pressure is held in this area here, all across here, and all inside the tube barrel itself, and down this section here. This area here, looking from underneath, is just the fire area. So let's move on to having a look at this tube plate then that fits inside here and is soldered into place. So as we can see, I've omitted the dimensions, but I've left some critical things in just to explain what's going on here. So this is the boiler barrel itself, and these are holes drilled, possibly reamed, or possibly even bored with a boring bar through these positions. This is the plan view looking into the boiler barrel, and this section here is looking at this same tube plate, but just literally turned on its side like that. And here we have something quite similar to it. That's the sort of shape that we're actually looking at here. It's the smoke box tube plate. So to note what we're seeing on this drawing, we can see that this outer circle here is a constant line all the way around, but this inner line is broken, full line broken, full line broken, etc. And that tells us that what we're looking at is this face of the boiler tube plate, and that this thickness of the return, this is called the flange. The thickness of the flange we are not seeing because we are looking at this particular face of this smoke box tube plate. If we were looking at it in this sense, such that we could actually see this thickness, if you like, this second line would be a solid line, much like that is. But because we can't actually see it, because it's shown that way up on this drawing, that's why that's a dotted line. So if the line is broken, it denotes the thickness of the plate, but that you're not actually looking at the inside lip of that plate. We're looking at that side of the plate, not this side. If you see an arrow across the circle and that symbol there, that means that the dimension that's going to be under this piece of cardboard is a diameter. So that hole size would be that diameter shown under there. You probably wouldn't be able to drill out that size, so you may end up boring that size to shape to fit the tube that's going in, because all of these holes here have a tube going into them, a hollow tube. These crosses that we can see here tell us where the centre of that circle is. So all of these 1, 2, 3, 4, 5, these 5 tubes are all in line with each other, and here are the spacings. This will tell us how far apart the tubes are. So we need to pick these dimensions up. Sometimes on the drawing that you're actually looking at, that dimension might not be there, but you'll find it somewhere else on the drawing when looking at another plate, for example. So you sometimes need to look at the part that you're actually making and look at another part on the drawing to find all the dimensions for that particular part that you're looking for. If we see this kind of a measurement with the lines projecting up to there, that tells us that this is the external diameter of this component. This is actually a bush that's fitted into a hole in the boiler to give the boiler strength. Otherwise this plate might tend to buckle. So that's a bush that gives us strength, and we can see with these 2 lines going round the circle there on the inner circle and this 32T, that tells us that under here is a measurement, and that measurement is a hole drilled in here and tapped. Because of the T, it's tapped, and the 32 tells us it's tapped 32 threads per inch. So for every inch of length of that bush, it would be 32 threads of the screwed thread per inch. When we see this piece here, under here is a dimension, and it tells us how far apart these particular holes are. And this is how we work up the dimensions that we're talking about. The boiler tube plate tells us that it's a tight fit inside the barrel. And as we spoke previously, there would be the black that we showed earlier of the silver solder filling that gap. Silver solder would hopefully go all the way along here. It needs to go all the way along the length of the flange. This would be the flange. And again, we would be looking at this flange in that sense, because this is just one line, which would be the end of this flange, but this side here is showing us two lines. The inner line again is broken, and that would denote the thickness of this wall here that we can't actually see. And there is the bush again with its threaded hole. And again, these lines are dotted because we can't actually see inside the bush. This is the end of the bush, and this is the length of the bush. We were talking about the 32 threads per inch. If that was an inch long, then there would be 32 threads along there when we tapped it with a tap. And then we would screw something into that with again a matching thread size. Moving further back along the boiler, we then come to the firebox tube plate, and this would go at the other end of the barrel to this plate here. And we can see that these two holes here on the front tube plate are also here on this firebox tube plate. We then also have these two holes, which are here, and then we move down to the 3 here, which are here, the 5 there, which are here, and a further 4 at the bottom. And all of these match up with each other, and a tube passes through these holes that are drilled in here from one end of the barrel to the other. Again, we can see here that that says rad, so that tells us that this would be a radius measurement, and the radius would be the external radius of this tube plate. And the radius, whatever that radius would be, we would come from that point to there. We put the compass on there and mark out the radius. Likewise at this side it would be exactly the same because it's symmetrical. We did not put the measurement on here, it's only at one side. But this arrow here points to the external part of this copper thickness that we're looking at. This is a copper thickness that we're looking at, and it's a plate that's like that. This is the side elevation. So here, because we can see a complete line there and a complete line there, we know we're looking at this side of the plate and not this side of the plate, because it's showing us the thickness. It's showing us the thickness of this piece of copper, if you like, when it's formed. That would be the thickness. If we couldn't see the thickness, it would be that way up, and this line would be a broken line. Again, this is a radius measurement from the top radius of that following back to the centre line here. Whatever that radius is, you would set that in your compass and you would mark that radius across there with your compass. On the corners it's a tighter radius, so you would pick the position for that and do that. Again, we've got the diameter diameter mark across the hole, and we've got the line here that tells us that they are all in line with each other. And here are the measurements. These arrows between these two lines here tell us what that measurement is, so we can mark it off. And again here, here's the measurement for there, and here's the measurement for there. That bears back now to what I was saying about on this drawing, if the measurements are not all here, if you can't see the measurements here, look somewhere else, because the measurements are on a relative plate that would match up with that. But we've just put the measurements on this plate and not drawn them on there. And quite probably, if you put a straight edge across all of this, you would find that all of these form in line. So that's the shape then of the firebox tube plate. That's what these drawings here are showing us. Quite simple. And the way that would be made is we would make a former as big as this. The plate would be cut oversized and then bent over that former into this flanged section here. More of that when we come to build the boiler. Here are the dimensions. External again. The line here is shown coming down slightly, and again here coming out. So these measurements are the height of it and the width of it. Here it tells us what thickness of copper this plate is actually made of. And as we can see, they're all of a similar thing. They're all 1/8 of an inch or 3 millimeters on metric.